All right, so in our last video, we went ahead and talked about slope. And I want you to remember that slope, we went ahead, you can plot 2 points and count rise over run. That's the first way we went ahead and looked at slope. And all slope is how fast or slow a line rises or falls. All right. We also talked about we could calculate it mathematically using a formula, which is y2 minus y1 over x2 minus x1. And so given any 2 points, I can go ahead and find the slope of the line that it represents. Okay, I obviously don't want to use a third point, right? The other thing we want to go ahead and talk about is this idea. We had talked about equations being in standard form, which is ax plus by is equal to c, where a, b, and c are numbers. And this is how the first time we saw equations, we went ahead, plugged numbers in for x, solved for y, and vice versa. This one we called standard form. Okay. And standard form also has some rules for a. Okay. So a must be positive. Okay, so some positive value. And a must be greater than 0. Okay, which means a should not be a negative number. And some of the equations we have seen that we have worked with did not follow these 2 rules, but if we want everything in proper standard form, these 2 conditions must exist, right? So now we have seen the slope-intercept form. So slope-intercept form is in the form of y equals mx plus b. You guys have talked about this before, where m is actually your slope. So if you have an equation in this format, you literally can look at m and say, oh, that's my slope. B is your y-intercept. Remember, your y-intercept is in the form of 0, y. Right? So looking at an equation in slope-intercept or y equals mx plus b form, we already know 2 very valuable things. We know our slope and we know our y-intercept. We can literally go ahead and graph a line based off of that information. All right. Right now we're just kind of interested in slope. So let's go ahead and look at the slope-intercept form. Okay, so if I want to go ahead and graph a line, I'm going to guess, let's say I have y is equal to 2x plus 3. And I just want to go ahead and graph this line. I know 2 things right off the top. I know that my slope is equal to 2. So my line should be going up from left to right, because it's a positive slope, and it should be fairly steep. I also know that my y-intercept is 0, 3, which means I have a starting point. Okay, so if I want to go ahead and graph a line in slope-intercept form, and we're going to do more of this further down the line, I know that I could start my line at 0, 3. Now from 0, 3, I have a couple choices. I think I need a couple hash marks here. Okay. I can navigate to my next point using my slope as opposed to plugging numbers in. Okay. Now think about this. My y-intercept, if x is 0, this part here goes away, and I'm left with 3. But I don't necessarily need to plug in another point into an xy table. I can navigate to the next point using my slope. And I can do this one of 2 ways. My slope is 2, which means as rise over run, it's 2 over 1. So my rise is 2, my run is 1. Okay, so that means from the point of my y-intercept, I can go up 2 and over 1 and have my next point. I can also go ahead and do something crazy, which means I could go ahead also, and remember, I could go ahead and rewrite it this way, because what if I run out of graph? Remember, a negative over negative is a positive, so this slope is exactly the same, which means I could go from this point, I can go down 2, and then go to the left 1, and also plot it, and they should be on the same line. All right, so you could go ahead and graph a line. If it's in slope-intercept form, pretty straightforward, because it gives you those two important pieces of information. Okay. Slope is nothing but a navigation from one point to the other. And in fact, if I even wanted to take this further, I could still, from this point here, go up 2 more to the right one, and I can get another point. And it still will be on that line. And I can do that for as long as I need to. So having an equation in slope-intercept form is very useful. It allows you to graph a line very quickly. All right? Well, what if I'm not given it? What if I'm given an equation in standard form? Well, you have 2 choices. If I just need to know the slope, I will need to go ahead and manipulate this equation. If I just need to graph it, I know I can use my XY table and I can be okay. But here I just want to get my slope, which means I need to get this equation in the form of y equals mx plus b. All right, which all it means is I need to solve for y. Right? So let's go ahead and take this equation. I'm solving for y, which is here, which means I need to get this 3x over to the other side. Now it needs to go over as a group. It also needs to be in the front of the 12 because of the format of the equation. So I'm going to subtract 3x from both sides. My 3x is going to cancel on this side, leaving me with just 4y is equal to, now I can't combine these are not like terms, negative 3x plus 12, because the x part has to be in the front. Then I need to go ahead and solve for y by dividing every piece by 4. Okay, so all pieces need to be divided when you have more than one thing on the left-hand side or right-hand side. So this cancels out, leaving me with y. Now, 3 doesn't divide into 4, doesn't divide into negative 3, so I'm left with negative 3 over 4x plus, now 12 divided by 4 is just 3. And so this is my equation. If I had gone ahead and done an XY table, let's look at that, for my original equation, and used my intercepts, if x is 0, I'm left with 4y is equal to 12. If I divide by 4, y is equal to 3. I get my y-intercept. If I make y 0, then I'm left with 3x is equal to 12. If I divide by 3, x is equal to positive 4. If I do a quick sketch graph of that, 0, 3, 4, 0, I can see that my slope is negative. And if I wanted to, I could go ahead and count and double check my slope. All right. So if we don't want to transfer this into slope-intercept form, then I just have to graph it like I did before, I like to use my intercepts. Okay, and you could just go ahead and graph your line from here. And I'm going to do it nice and big on this page. And I got 4, 0. I have 0, 3. And from here I could go ahead and count. So if I rise, I go up 1, 2, 3. If I run, I'm running backwards, so it's negative. 1, 2, 3, 4. And I have the same slope that I got right here. Right? So there's a couple different ways you can approach this. I hope you try it each problem a couple different ways so you get comfortable with it. I will see you in the next video. Make sure that you try to practice and ask any questions if you have them.